All right. So hopefully everyone can see my screen with visuals, with the ever so exciting Visual Studio showing. Hopefully this will make sense. And I'm hoping you guys had a chance to sort of dabble in classes. I can do another simple example of a class just to give you a feel for it. Uh, but I'm hoping Simply Human will actually do, or the human class will do things. So here's what we're trying to do. The difference between a procedural language and an object-oriented language is sort of the perspective that you're taking. And so there are some people that are very like, oh, object-oriented. I mean, it's been a long time since this happened, but a long time ago, people would balk at the idea of object-oriented programming. Some people, because in some cases, it's not the right solution. For a lot of times, if you're dealing with a server, for example, C is just fine for you. Hell, Python works for it as well. C is extremely powerful, extremely efficient, and it can go on a chip, right? It goes on a little, it's one of the default languages for like a Raspberry Pi, but it doesn't work in all cases. Oh, it works, but it's a real pain in the backside. So if you're talking about a graphic user interface, for example, like like Visual Studio, right? How do I define how this button acts? How do I define how this works or this works? If I use a procedural language, I need to sort of organize my code in a certain way, and I have to think about I'm sort of passing messages back and forth. But what I really want is this button here knows what to do with itself. It knows how to draw itself. It knows how to interact with a mouse event. It knows when you click it, what it does. Then conceptually, how we as people think about this is how we want our code to look, right? We don't want to get in the way of how we're thinking. So when I'm dealing object-oriented programming, it's how I think about the world is how I want the code to look for the most part. So what I want is the data that I make to be in control of itself. And that gives me a lot of really crazy things that I couldn't do before. So not only does it allow me to say, hey, string, how long are you? Which a lot more intuitive than I'm going to call this string len class and pass in this string. Right? I just want to say, hey, string, how long are you? We've already looked at strings. But on top of that, how are strings implemented? I don't know. You shouldn't necessarily know either. What I want is the tool. I don't want to know how it's built. I don't want to know how it works, how it's all put together. I just sort of want to use it. I don't want to know how the sausage is made. I just want to eat it. So that's the same thing. I don't want to know how my phone works, right? I just want to use my phone. That's what we're dealing with here, that the object knows how to deal with itself. You pass data into it, data comes out of it, but you don't know how the implementation details are there. So here is the human class. And I'm just going to go to what the human class looks like. So uh, here would be an example of just some random normal C code, right? I call this function foo, it does something. Foo does not have to necessarily do anything at all. I mean, just in this case, it does the same thing each and every time I call it. Foo is actually, I want to sort of test some of these stuff. Because foo here will be, I want to remove the word foo here. So what am I doing? I'm going to make a class called human. Very original. I could call it whatever I want. It could be any topic I want, really. In this case, I'm making a human class, and every time I make a human, it does something. Some things happen every time and so in this case, maybe I'm getting ahead of myself. Maybe what I'll do is, why don't I want me to make a brand new class? Yeah, let's make a rectangle class. I'm just going to leave this alone and make a brand new rectangle class. So make brand new project. All right, I'm going to back a couple levels. 1400. Just like that, right? Oh, the thing class. what I call it Sync2. I think we're well past lecture 2, but call it Sync2. And we're going to call it rect. And we're going to call it shape classes. All right. By the way, again, if you have questions or if there's something, I'm just talking because no one's talking. That's all I'm doing. So if there's a topic you want me to go over, speak now or speak afterwards, because I don't want to be rambling on and find out that you guys were all waiting for me to say something else, right? I'm just talking about objects because that's what assignment 3 is all about. Now, assignment 3, we're doing the same thing as we did last time. We had a tree, we have a tree structure before. We're making a tree class now. But do we need to do that necessarily? So I'm going to make a brand new class. It's not really a class, although it says it's a CPP file, and it's going to have my main. So IO stream, standard IO, save string class, and I'm going to include. We're going to find out if standard IO EDIO. Okay, we're going to throw that in there. We're going to enclose some inserts. Why? Because we can. And then we're just going to do a main. All right, I'm going to make and then I'm going to okay, that's what we're going to be doing. Something fairly simple. I'm going to make, I like this as an example. Maybe you don't, but I think it's fairly simple and easy to do. I'm going to make a rect class. Why? Because rectangle. Rectangles are very useful. Points are very useful, right? I want some kind of data structure, like some kind of shape. Now, we could have made a rect struct. In the past, we would have done this. We would have done something like this. Struct old rect, and that has int x, int y, int width, well. And then if I wanted to get, let's do the old way of doing this. And then I would have some function called get area. Okay. And then I pass in an old rect. And I want to get the area of this rectangle, right? Let's say, for argument's sake. So, or maybe, well, why don't we do this? X1, Y1, X2, Y2. Also define 2 points, right? Any 2 points in space. We'll define a rectangle. Rather than having a width and height, I could just have 2 points. X1, Y1 is 1 point. X2, Y2 is another point. I could also make a point structure if I wanted to do it that way. Okay, that's fine. But I'm going to just pass in an old rect, and I need to figure out what the area is. Okay, so what could I do here? Well, to figure out what the width is, so r dot x2 and r dot x1, and I'm going to do the same thing for my width. Oh, sorry, my height, sorry. 2, it was 1, it's a y. All right, and then I return width times height. And as you might hopefully realize, that's wrong. Why is it wrong? Because what if x2 is smaller than x1? I got a negative area. What? Yeah, I don't want that. So what I could have is something like width is equal to with just so we can look at ternary expressions because I know how much you miss them. I can do something like that. All this laziness of using cut and paste, no reason. Yeah, I should have just wrote it out. Oh boy. Okay. And maybe I want to test these things out. So let's put something in here. And I'm going to make old rect r is equal to 2, 4, 6, 2. And what I expect in this case, I'd expect the difference of 4 between x1 and x2. So 4 between these two. And the difference of 2 between these two. So 2 times 4, 8. I would expect that to be my return value. So assert uh, get area of R is equal to 8. And I'll just compile it and see what happens. I also need to return something. All right, another thing blew up, good enough for me. I should test this out in a whole bunch of different inputs, that sort of thing. But that's not what I'm trying to focus on. What I would like to focus on is why the hell do you need to know what get area does or how it works? I want to use a rectangle. The rectangle I should be able to use a rectangle. I shouldn't actually have to know how it works or how it's implemented. Am I using x1, x2, y1, y2? I don't care. Could I be using width and height? Sure. I don't care. Maybe I want the height, or maybe I want the width. Well, maybe I don't want to have to figure it out on my own. So let's make an object that handles itself so that when I make this object, I say, give me the width. And it goes, here's the width. Give me the most extreme, what's the minimum point? Here it is. Here's the maximum point. Here it is. That I can make this thing without having to know how it's built. That's what I want. So I'm going to do that same class without a struct. I'm going to do it with an object, and then I'm going to use it and not have to worry. And it's going to be a lot more code, but it's going to mean that I'm not trying to figure out like, oh, well, it's implemented this way. Get area I just say, get the area. And the person using it has an easier time. The person writing the code might have to write a bit more code, but the person using it has an easier time. And conceptually, it makes sense. The rectangle tells you how big it is. Okay, so let's make one of these classes. I'm going to add a new class. Why? Because I can. And it's called NewRect. Notice the naming scheme. It's something that most people don't notice, but I just like pointing it out. By convention, our classes are named with a capital letter to start. By convention, every instance of an object, every variable that we have, starts with a lowercase. Struct supposedly also start with a lowercase. I always did them uppercases when I was programming, but I looked it up. But I have this class called NewRect. It's going to do not a lot. Okay, but let's see it in action. This is going to make two classes or two files. It's going to make a file called newrect.h, header file, which is just the blueprint of everything. And then it's going to make something called newrect.cpp, which is how everything's done. Okay, so let's do. So I want. I'm going to do things the wrong way at first, and then we'll get to the right way afterwards. Okay, so the wrong way at first. Int x1, int x2. This will, for all intents and purposes, look, act, behave exactly like our struct did, doing it this way. Don't do it this way, but this way it would look, act, behave exactly like a struct did. And then I can have something like int get area, which I don't need to pass any data into because I'm in the rectangle. The rectangle's telling me how big it is. You don't need to pass the data for the rectangle. The rectangle knows what it has. Okay. I also want to have um, some new things here. Hopefully that's spelled right. Accessor. The ability to get access to something. Maybe I have something like, maybe I want this. What do I want here? I want to do it a particular way. That's why I'm humming hawing. Let's do it this way. Int x1, int int x2, int y2. All right. That's going to be my constructor. I can also have blank constructors. So I have a getter method. I can get the area. Maybe I can get, maybe what I want to do is get the minimum x. Maybe get the minimum y. Get the maximum x, maximum y. So all right, I'm going to make all these functions in a second. And I have this global variable. Okay. I'm now going to have to fill in all of these functions. Okay, so let's do that. But effectively, when I make one of these things, I will have 4 numbers associated with it, x1, x2, y1, y2. And I will have some kind of a bunch of functions that also go along for the ride. Free functions that allow me to access and deal with that data. That's what we're doing here. And it doesn't make a lot of sense. It doesn't, why would we do something as insane as this until you play with this enough? And then you go, oh, that's why. Now, I got, somebody was saying, you could do this. And then I should be fine for most things. I don't tend to do this, but that's just me being a creature of habit here. So my normal way of doing a class is do the following, but I'll show you in action in a second. So notice it's including, at the very top here, it's including this header file I just made, which has all of my blueprints, like all of the different things I have. And then I'm going to define each of these functions. My way of doing it, and you can take this with a grain of salt, I suppose, is I do this. In the class NewRect, define the function NewRect. It's called a constructor. In the class NewRect, define getArea. In the class NewRect, define getMinX. In the class minY. In the class NewRect, define getMaxY. That's what that's doing. So this little thing here is to let me know, okay, in this class, I'm going to go in the class and define it in there. So I'm going to actually just get rid of part altogether. And then this thing here is going to be, oh, I just figured out I have something. Oh, we did look at this pointer. So we have a chance to use this pointer. Oh, okay, here we go. This x1 is equal to x1. We can look at this in a sec. We can look at what the heck that means in a second. Okay. What the what? What's going on? So a couple of things I have to worry about. I could do things. I'm going to change this up in a second, but let's have a think about this one. If I take in these values, I have a brand new variable called x1. So when I call x1, if I use the word x1 in here anywhere, it means by definition, the thing that has the highest priority, that bonds the most tightly, is anytime I talk about x1, I mean the parameter coming in x1. If I want the member variable, the thing over in here, this variable here, x1, not the input parameter, but the data that's stored in my object. Every time I make an object, I get this data in there. If I want that one, that's where the this keyword comes in. So I go, in this object, that variable, not the parameter coming in, the member variable for this object. That's what that this keyword is referring to. The object you're dealing with, yeah, okay, this guy, right? That sort of thing. It's this object's member variable named x1. The reason I use this all the time is because I'm a lazy jerk. I'm really lazy. I forget the names of my variables. I forget the names of my functions. I forget everything. And so I go, I don't know what that was called. And I write this, I put an arrow, and it does an autocomplete for me. And I go, oh, that one. Okay. I write that. That's the only reason I use this half the time. But this will do. Sure, if you want, let's use a different name. Great. Um, what do you want to call it? Oh, px1 for point x1. You do that. It will make no difference. I can't even leave on this pointer everywhere. Py, px2, py2. And now I have to use px1, py1, px2, py2. In case YH. What's the H for? Out of curiosity, it could make perfect sense. I just don't know what the H would be for. If it's in the header file, the H for the header file, that's the member variable. And that's a different, that's still this x1, x2, y2, y2 thing here. For the parameters coming in, that's what we're using this for. So hopefully that makes some sense. It's the parameter or point x1, all these places. So I'm setting up my variables. Great. How do I do my area now? Well, what I could do, let's think about this one. Well, let's do the other one first. Okay, so what's the minimum? So I could say return x1 is greater than x2. If and that's the case, then I'm going to put the minimum, right? So x2, otherwise x1. So if x1 is larger than x2, I return x2. It's a minimum, right? This is our minimum. I'm going to be lazy and I just type it out. Sure. And I'm going to be lazy now, though. I know what I'm going to be doing. I'm going to say if this one is considered equal. Okay. So this will just return the smaller of the two numbers. Okay. Oh, you can. You certainly can. Let's plop one in there. You don't need to in this case. I needed this keyword before. I needed the this up here. I only needed it because I had an ambiguity. I had two things named x1. Which one? I needed to differentiate it. So let's remove one of these two. Notice the this There's no ambiguity. So I can use this, I can leave it off, I can do whatever I want. It will make no difference. It's the same as just saying X1. It's just I forget the name of variable. So if I put this and put the arrow, I get it autocomplete. That's it. Okay. So I have all these methods to get the minimum value. So if I want to get the area, what could I do? Well, why don't I use my own functions? Why don't I could do the same thing as I did previously, but why don't I say uh, int width is equal to get max x minus get max y. Is it slower? Yeah, it's a little. It's all of 2 milliseconds slower. It's along those lines. Y, y, and this is that's min x, min y, max y. So the maximum minus the minimum. That's going to be my width and my height. Okay, same thing as I did last time. The math is the same. I get the minimum. I get the minimum. I take the difference between the two. This is guaranteed to not be a negative number. It could be zero, but it's not going to be a negative number. Okay. Return width multiplied by height. So my functions can call their own functions. That's fine. No harm in that. In fact, it's actually good practice because what I'm going to do after this is I'm going to change. I could change this. And if I change this, I want to be able to, if I implemented it a different way, no one needs to know. No one needs to care. I just implemented it a different way. So let's see if I can compile this thing. All right. So I'm going to go to my source. I'm going to make new rect r2, and that's going to take in some values. So 2, 4, 6, 2. And I need to include. Notice what I have there up here. I need to include the header file by itself because I don't know which order this gets compiled or this gets compiled. It gets compiled in some order. But in order to know about this other class, this magic other class called NewRect, I need to include it. That's where the quotes come in as well. It's a local file, not like assert, which is on the file. It's like in our major libraries. This is a local file right next to me called NewRect. That's where the class is located. Ah, but I'm not defining functions. That's a great question. I'm not, this is me defining the functions in NewRect. This is, I'm just using a NewRect. So I can just directly use it. Once that, when I'm defining the functions, I use the double quotes, say like in the class NewRect, this is me defining that function. This is, I'm just using it. Yeah, it does take some time. Okay, and then I'm going to do another thing. Let's try this. R2 dot. There. And let's do that same assert. Get area is equal to 8. Should give me the exact same value. If it doesn't, well, we're going to find out the hard way. So compiled, I think, and let's just run it and see what happens. Oh, I got to move this over. Nope, nothing happened. If you want, we can even put a breakpoint in there. But this thing, get area, is returning the value 8. Same as what we did before. And you'd say, well, why are we wasting our time doing this kind of crazy crap? We did after all this extra stuff. So let's figure out why we're doing all this crazy crap. These are great questions, by the way. So keep them. So why are we doing this? Well, What I might want to have is, what if someone says, no, 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 change it around. I don't want X1, Y1, X2, Y2. I want, I want X1, Y1, or X, Y, width, and height. I don't want to know how it's implemented. I just want it to work. So what I could do is completely change the implementation of this class and use it. That's the point. And you might think, why do I need to know this? And I would say, how does cout work? I don't know. You don't know. How does the file input output stream code work? How does the string class work? Half the stuff we've been using, at least especially since 2400, you have no idea how it's made, how it does things, and yet you can use it. You don't have to know what kind of data it uses. You just use it. So I make a string and I just get things. I can concatenate with a string. I don't have to worry about like, oh, a string is an array of characters with a 0 at the end. No, I just concatenate things. I don't want to have to know how things are built. Okay, so I want to try that out. Let's see if I can break it. I want to do one thing first, because we have one other problem here, and I'll show you in a second. So I could do get area r2 dot x1, r2 dot x2, y1, r2 dot x2, r2 dot y, y2. Right now, that's permitted. Oh, good God, you shouldn't, at least maybe it is. It should be. Oh, I'm passing in an old rectangle. Sorry. Uh, just move it and make a new old rectangle. I'm just making some stuff up here. There you go. What's that? I should know how it's done. I don't want to know how it's implemented. I want to be blissfully unaware how it's implemented. I don't want to know that it has these 4 data points. So this, very, very bad idea. Okay. I don't want to know how this thing is built. I just want to use it. Okay. Yep. I just want to not to break down. Yes, that's a perfect analogy. Right? I'm a terrible driver. I shouldn't, and I really should not be a mechanic. I know nothing about my car. I can still drive. I can't change my oil, but I can still drive. I can change a tire. I'm up to that level. Right? I'm not great with a car, and nor should all of us be. We just want to use it. You don't know how your phone's built. Um, Therein lies madness. If you tried to understand everything about the entire modern world, you'd be driven mad. It's the same thing here. So here's what I'm going to do instead. If I can type, that'd be awesome. This is a brand new thing here. Public and private. And we're going to look at this in a lot more detail when we hit inheritance, especially the end of this lecture series for objects. A private function or private variables mean the class knows about it. So I have an object of type rectangle, a new rectangle. It can know about its own member variables. No one else needs to know. It's you and your student ID. No one else needs to know about what your student ID is. You can give it to somebody, but they shouldn't be able to change it on you. It's yours. Your social insurance number, same thing, right? It's yours. It's for you to give out for people you trust, but you don't just leave it around willy nilly. The same thing here. I want member variables to all be pretty much all my member variables to be private. I don't want anyone else looking at these things. You can make them public, but don't. And so now they're private. Okay, what I should be able to do now is compile it. Great, nothing, no problems happen. And now let's do Let's leave those in there for a second. Okay. Um, it's a min x min y. All right. It's going to break. That's fine. I'm okay with that. All right. How do I figure out what to do here? I could say instead of this, what I need to have is min x is equal to px1 is greater than px2. If that's the case, px2. And actually, I should be able to just use this whole thing. Oh no, because I have px2 instead of that. Okay, I'm just going to move it this way. On px1. Maybe then I want the same thing. Okay. I need to, so what I need to do here, I need to figure out the difference between the two and take that difference. Okay, so now I could try and do this, use this min x, but we're going to use that in a second. Um, Private is it's only available, only visible to the class and objects of the class itself. So any rectangle that I make, which is an object, not the class defines how a rectangle is formed, like the blueprint, like a human is the blueprint, but I am an instance of type human. An object of type human. A class, anything, any object of the class, so any a human would know about its own information. Let's say a rectangle knows about its own information, but others outside will not know. It's specific to just that. So, but private functions, private variables, they're slightly different, but they're, yeah. The fact that they're private means only they can see it. We also have protected, which means I can see it and my kids can see my information, like things that are part of my class hierarchy can see it, but that's it. So we'll get to that in a little bit. Okay, and what's this going to be? Oh, I'm going to use the same logic as before. I'm just going to slightly change it. If the x is greater than p this, then I want p x2, p x2 minus p x1, p x1 minus p x2. And we'll do the same thing for my height. Let me know if I forget a y in here somewhere. And my height. So essentially, when I'm making this object, I'm figuring what the minimum is and setting it. So I have the minimum x, I have the width and the height, getting the area. I don't have to do that anymore. I just say, let's comment it out. I have something called width, I have something called height. Done. All right, get the minimum x. Get the minimum y. Get the maximum x. Well, that's the minimum x plus width. That's the maximum y value. Not a damn thing changed. I've completely revamped every part of my class. I don't think I had a single function a single function in here that did not change in some radical way. And yet nothing changed and the main code didn't change. The person using the rectangle class, my main function, blissfully unaware, did not have to know anything about what happened. I made a radical overhaul of my entire class and no other code had to change. So that when I build something, let's say I'm building a car and I rip out or if I'm building a computer because that's what we do, right? If I swap out the hard drive and I don't have to change any other components of my computer, that's a win. Ever try and swap out the motherboard and not change everything else? It's a big pain. There's a whole bunch of codependencies. This means I get to swap out one thing and I don't have to worry about it. If I have a really good interface, I don't have, oh, this plugs into this and this plugs into that. I just have a plug. I pull it out, plug in the next one. Good. We're good to go. Okay. Nothing has changed. And yet I've completely overhauled this entire class. That's why we do it. Okay. What else could we do? Uh, let's see. What would be another really good thing for me to do in my class? Oh, I got it. How about um, let's do string class and get get info, whatever we want to call it. Okay, I'm going to need a string class, I think, in here. So, all right, I'm going to return a string and this. Let's find out what's wrong with it. Already includes string.h. The semicolon at the end. All right, is that a problem? Yes, I didn't need std yet. Okay, so I'm going to get information about the string. Okay, let's see what the question is here. What makes functions get area, get min, get x have access to the variables of the new rect function? Is it new rect colon colon? Yes. The functions themselves, I'm saying every single object of type new rect, every time I make a new rectangle, I get access to these functions. I define those functions in the CPP file, but so they're defined for the class. And because they're in the class, they're in between here and here. They're in the class. Because of that, it means it has access. It knows what's allowed to see it. Only things defined between those curly braces are allowed to access those member variables. This happens to be, okay, I'm going to define that member variable later, but the only things that are allowed to look at these member variables are these functions right here. All right, which means that's why we have accessors, as in the ability to get that data. But notice when I return an integer, you're still not changing the object. I'm just giving you a copy of what the data is, but it's not, you cannot modify the data directly. And so when I can get it, I can also set my values, which is not going to be very useful. It's going to be hard to deal with for this particular example that we have, but sometimes I want to set something, the setter method or a mutator as the proper term is, right? I don't want to directly access it. I want something that prevents me from doing something stupid. So we'll get to that in a second. I'm going to make another class actually. So let's do the get info. Okay. So I'm lazy. I just copy and paste all the time, just in case I spell something wrong. Okay. And I'm going to new rect. All right. I have this function called get info. It's going to return a string. So what am I going to do? I'm going to make a um, okay. And let's make it an empty string. And we start. what do I need to do here? Text, data, DXD. And why is that not? It should automatically be filling that in. I'm going to just use standard namespace. I am using. That's why I don't do the namespace rectangle, because I'm really, really lazy. Okay, I'm going to get rid of this. I'm going to get rid of this. I'm using the standard namespace, so I don't need to put that std thing everywhere. Okay, and what's this going to do? This should. Why is that not showing up? This is actually me legitimately not knowing what the hell happened here. Let's just make it string. Because it's default constructor. Okay. I'm used to calling new everywhere. We can look at new if you want as well. So I have some string. I'm going to append. I'm going to append something on here. So let's see what I can append onto this thing. I'm going to append onto it the string version of, I think this is it integer to string or string? I'm going to blank. I'm blanking on this thing here. For the string class, I need to, I'm taking a number, so I am going to and I'm going to I'm just trying to figure out the right way of putting that number in there. That's all. And I can't append just min x. I don't think I need to convert the min x to a string. Let me try and figure out this. Oh, integer value. Integer. What is it? String. Oh my god, I'm blanking on the terms. To convert something, an integer to a string, I would need. I would normally Google this right about now. If you know it off the top of your heads, that's great. I think we even used it in the last assignment. I would just Google it normally for myself. So, because what I want to do is I want to append this string. I know the append method does not take in a number, it takes in another string. And so I need to convert this minimum value to a string. I could just use cout, but I didn't want to use cout. I wanted to make a string and pass the string off. So what is my thing? Let's just, well, is it toString? I think it is. You're right. Horrible. Yes, thank you. In X, there we go. I can just use that entire thing in here. And I can do this actually. You can concatenate strings. Okay, and then And some of this weird fiddly stuff that you can deal with. All right, so I'm appending this plus this plus this plus this plus this, the width, and plus the height. I forgot my plus in here. Okay, and then we'll just return. Oh, it's uh, it, problem is okay. And let's do this. See out. I might have to deal with this. Um, oh, I'm missing. It's not name standard namespace. It's IO stream. There it is. Oh, nice. We got something. So let's have a look. I just made a function. I want to see it works. I'm not moving on until I test it. And maybe I would. The better thing would be for me to actually do a bunch of different tests. Rectangle 2 is rectangle's numbers are okay. The text message is not that great. Should change that a slight bit, but 2, 2, uh-oh, -4, -2. I got something wrong with my code. I got to fix it. Okay, what's wrong with my code? I think my width and my height calculations are wrong. Let's have a look. My height, if the, let's see here. If x1 is greater than x2, then I'm, oh, yeah. Let's put this around. If y1 is less than y2, then y2 minus y1. Otherwise, y1 minus y2. All right. All right. Width is 4. The height is 2. The rectangle's numbers are 2, 2, 4, and 2. I will look at my code again just to be on the absolute safe side. Uh, the minimum y is 2. The minimum x is 2 over there. It goes from 2, 4 to 6, 2, but they're opposite ends of a rectangle. Let's try another one of these things here. Let's do that R3 again. Let's call it R4. Okay, and R2. Look at all the code I had to write for this. I had to make one and call print. That's it. All right, let's have a look at this. And R4, the rectangles 2, 2, 4, and 2. So, I forgot to change the numbers again. Okay, let's change the numbers. Let's do 2, 4, 2, and 6, or maybe -2 and 6. No, that's going to be worse. So what I expect is -2 and my numbers are going to be a little wonky. The minimum values are going to be 4 and -2, going up to 4 and 6. Or, sorry, -2, 4. going up to 4 and 6, the other coordinates. -2, 4. Is that what we want? Okay, let me move this over. -2, 4, yeah, and it's going to 4 and 6, so the difference is 6. Between -2 and 4 is 6 points, and between 4 and 6 is 2 points. So the height should be 2, and the width should be 6. Done, done. All right. That's what I want to look at. Maybe I will look at 0, all them being the same value. So the width is equal to 0. The height is equal to 0. Make sure that that works. I want to test a whole bunch of cases. I want to try some negative numbers. I want to try a bunch of numbers. That's what I'm just playing around with, making sure that my code works before I move on. Normally, but limited time. I'm going to do one more class. I'm going to do a point class because I'm going to do a setter next. So let's do, and so this printing out thing, by the way, kind of useful for the assignment. That's actually how you would print out things about your tree, for example. If you want to print out or get the information for your tree, you can use that same kind of a technique. So I'm going to make a new class. And I'm going to call it, oh, there you go. New, as in NEU. Ooh, yeah, look, ooh, fancy. Kind of look all cool with our bad spelling of things. Okay, I'm going to make a new point class. All it's going to be is a point. Done. Okay. It's going to have, I'm going to do that private thing as I had last time. By default, by the way, the default is protected. So half the time I get into real trouble when I code something. I'll forget to put that in there. And then I'll go run my code and I'll be wondering why the heck I can't find that variable or I can't call that function. And it's because it's a protected function instead of a public function. You have to be very explicit about these sorts of things. So int x, int y, and I'm going to have new point. Do I want a member variable? Yeah, sure. Let's make int. I'm going to do a getter, some getters and some setters. Okay. So all right. So my getter methods, get x. Here are my setter methods. Sorry. Setter methods are often void, as in I don't want to return something. I'm just changing it. Change it for me. Void set x. We'll see why I'm doing this particular example in a second. So this will change my values for x and y. Okay, I'm going to also be lazy. I know I have to fill in all these functions, so fine. There's new point.cpp. And here comes the laziness. So lazy. All right, here we go. I'll review to, is it? Here are my getter methods. Notice the getter method doesn't actually change anything. You want me to stop doing the lazy thing? I'm more than happy to. I just figure you have limited amounts of time. It's copying and pasting. I figured you wouldn't want me like type. And you can be lazy too when you're copying. Okay. Now let's figure out, okay, so set method. Okay, X is going to be, oh, I need to, I set method's wrong. Let's go back. What did I do with wrong when I set method? What's a set method for? I can't believe I missed this. What's a set method for? For setting things. How do I set things? I have to pass in data. Did I pass in data? No, I didn't. I did not pass in squat. I got to go back in here. Okay. Int new x, int new y, something like that. Okay. That's the setter method. That right there is a setter method. I don't like, it's useless if I'm not passing in any data. Int new x, int new y, y is equal to new new. And by the way, this is an example that I literally hit when working at Kotoka Interactive, making a video game, a children's educational video game, wondering why setter and getter methods were so important and all this kind of stuff. And people kept on saying, "Oh, you should always use them," like stupid things, manually changing numbers. And then I found out why you use these things. Even when you don't need to use these things, you use these things. We'll see this in about 2 seconds. Okay, that's all well and good, right? We're going to compile it, make sure it works. Okay, I'm going to go to my source. I'm going to also include, should move this down one line. Lines. I like having all my main libraries up there and then all my other stuff down here. New point. Okay. So I can make a new point, whatever the case is. Here's where the fun begins. Okay. And I'm going to pass in some value 3 and 5. I'm going to pass in some value negative 17 and negative 3. That would be perfectly acceptable. Except, let me see here. There's a good example. See my mouse? What's happening there? I'm bashing up against the top, and it's not going below 0. Why? Because I don't want my mouse going beyond 0. I'm going to get lost. If my mouse can go off the screen infinitely, you can make your matters worse and worse and worse. You're in like negative 4,000. You have no idea where your mouse is, and you're just moving it around. I want something that has a hard limit sometimes. If you want to say you're not allowed to give me a negative number, you don't let them give you a negative number. On a web page, when you type in and they say put in your, your student number and you put in your name, what should it do? It should slap you in the face and say, stop putting in putting in your name, put in your student number. You should validate data coming in. And that's where the setter comes in. Because if I write the setter once and I do it right, I just keep using the setter everywhere. And I don't have to have all these like, and if this is the case, then do this. I just keep on calling these functions that are already safety checked, right? I make sure it can handle null or whatever the case is, and it handles it correctly. One place, one time, correctly, rather than having to error check everywhere. I just call set x. So in this case, I'm going to change something here. This will compile just fine. I'm going to print out, do a CM statement. Oh, I need to do that standard cout. P2 is P2 dot get x. Notice I have no ability to get x directly. I can get it through this. P2 dot get y. Um, why is that acting on me? Oh, semicolon in there. Okay. So what this thing is going to do is it's going to spit out negative 17 and negative 3. If it compiles. It compiles. Great. Negative 17, negative 3. Okay. What if that's not what I want? In fact, I should probably even put. looks prettier this way. What if that's not what I want? What if I want to make sure that my point is always 0 or greater, that it's never allowed to be a negative number? Maybe I'm not allowing negative point values, like for mouse coordinates. Excuse me. If that's the case, then I want my function to handle it. I want my setter function to handle it. So let's go back to my setter function. Here is get x, get y. I don't need to change that. I could if I wanted to, and I could modify it there and make it positive each time. But maybe I don't want that. Maybe what I want is the following. Okay. If new x is greater than 0 or greater than equal to 0, just gotta move this around here. Boom. What's this going to do? If I try and give it a negative value, don't listen. You're negative 17. No, I'm not. Right? Clean your room. No. That's essentially what you're doing here. No, I'm not negative 17. Go away. I'm not even going to listen to you. I'm not going to, I could give some kind of error message if I wanted to, but why? You're negative 1. No, I'm just going to ignore you, essentially. Um, This is what we ideally want. Not for you guys to ignore me. Like if I say you need to study in advance, most students go, yeah, whatever. I was the same way, right? It's easy enough to do. We don't want that, but in this case, it's perfectly acceptable. Just yeah, don't do this. Whatever, buddy. You're negative 17. So that's what I'm aiming for here. And if I'm going to do that, what I should do is this. Set x, p, x. If I want to be really, really paranoid, I could do things like this. X equals to 0, y, just pure safety method. So that even if you gave me a negative value for px and py, it still gives me, it has a safe value to start. And then I just call set x, and if it doesn't like the number, whatever. Don't, whatever, buddy. Don't. I'm not listening. All right, and let's roll it, and let's see what happens. I want to do one more of these because that you might think I'm just it's all you know smoke and mirrors here. So let's do this one here. So let's do change this one up here. P1 is 1, P1. Oh, I got a problem here. Nice. What was my problem here? 5 is it's being set to 5. I think I know what the problem. So what could be causing that? That's the first thought I have in my mind. Right? Why is the x value wrong? It's 5, but it's supposed to be 3, and the y value, which is supposed to be 5, is 0. So I like thinking about what the possible cause of this is before I dive into the code. Right? What could be causing it? What screams to me is the y is in the wrong position. I almost guarantee you I called set x twice, didn't call set y at all, and so I set it to 3, and then I set it to 5 immediately afterwards. Let's go look at it. Yep, copy and paste. Burned me again. All right. And then I check another input because I want to make sure that these things work. Let's try one more. what the hell? It doesn't take much time to run one of these things. I'm going to make a P3, and instead of this, I'm going to put a -5 for Y. 3, 3, 3. Okay, let's roll it and then see what happens. Oh, you didn't see that. 3 and 0. That's what I expect because the -5 was wrong. Maybe I can also do another test and say P1 dot set X, no, set, yeah, set X, and I'm going to make this -17. See if it changes anything. It shouldn't change anything. The number should be still the same because -17 is not a valid input. And I check and I ignore anything that's not a valid input. Not a valid input, data didn't change. The point of object-oriented programming is that's how I want to think about my data. I don't want to have to think, I want the point to know about itself, the point to check for errors in itself, the point to tell me what it's, how it would be printed out as text. I don't want to think about like, oh, this is a struct and I know how it's built and now this all connects together. And so we just made 2 different classes. That's what the assignment is, make 2 classes, make a couple getter and setter methods. This is essentially the equivalent of the first week of assignment 3 done slowly. So it shouldn't be that long in terms of your coding, especially considering you've seen it before. You did assignment 1. Uh, does anybody have any questions right? It's 5:16. I'd like to get you guys done early. I always talk too long, but I want to unpack things for people if people are stuck on anything. All right. Good to know, Daniel. Anyone else? Otherwise, I'm going to take my leave of you guys and I'll post this video online. This code is actually on the code repository that we have. Perfect. No problem. Just listening. With just listening, especially considering we don't have something due this week. But I'll post it on the code repository. This code is up there for you right now. And on top of that, we'll post the video itself. I have a video for assignment 3, I think, already recorded and posted in the assignment lecture, the assignment video list or playlist. There you go. The assignment playlist. So if you want to have a look and if you need more help with the assignment, that's hopefully should explain some things. All right. Thanks, everyone. Stop sharing. And thank you very much for listening.